Hi, I'm Aishwarya. I'm currently working as an assistant professor at SNS College of Engineering in the Department of ECE. So today's topic is Monostable Multivibrator. So it is also called as one-shot multivibrator. It has two states. One is stable state, another one is quasi-state. So this quasi-state is also called as unstable state. Okay. So this is the diagram for this monostable multivibrator. So here we have one transistor and two op-amps. So this op-amps here we consider as comparator. So this is the comparator 1 and this is the comparator 2. Comparator 2. Okay. And we have flip-flop. This SR flip-flop here we use, and RA and C, it is a component of this monostable multivibrator. So here we used 5 kilo ohm, 5 kilo ohm, 5 kilo ohm resistor. So 3 resistor of 5 kilo ohm, so that it is called as 555 IC under the monostable multivibrator circuit. Okay. So 555 IC pin diagram already we discussed in previous session. So you just remember that. So it has 8 pins, right? The third pin is output, second pin is for this monostable is trigger pin, and 4 and 8 pins are VCC. Okay, so let us discuss about the function of this monostable and how it works. Okay, a multivibrator is used to generate, or it will produce the output, and it will generate a waveform. Okay, so this is the diagram. So initially we just assume that the output is 0. Initially we assume that output is 0. Okay. So the Q bar is 0 means the Q value is 1. So this is the flip-flop function, right? So Q bar 0 means Q value will be 1. So this one signal is passed to this transistor. So this transistor will get the 1. So 1 means it is a high signal, so that the transistor will enable. Okay. So this signal is given to the capacitor. So now capacitor will discharge the signal. Okay. Discharge the charge signal. So this signal is passed to this comparator 1. This comparator 1. So discharge means there is a low value of signal. So now this comparator 1 will start the comparison. So the 2/3 VCC and this low value. So it compares the value and it will produce 0 output because of this low value. Okay. This non-inverting output will be high. 2/3 VCC means comparatively it will be high, so that the comparator will be produce the value as 0. Okay. So now this signal is given to the set and Q. Now Q will be 0. Now Q will be 0. This is the common function. When it 0 means, see, this 0 is again flow through the resistor and given to the transistor. Now the low signal will be given to this terminal, so that the transistor will be disabled. Okay. Now there is no connectivity between this pin and transistor. So now the capacitor will take input from this VCC. So this VCC through RA, it now charge the value. Now charge the value. So that this signal now given to this comparator. Now this signal is very high signal. So high and it's very low signal. Now the comparator will be produced the output as 1. So okay madam, set and reset. So you just explain the process of this Q only. What about the comparator 2? Okay. So in this monostable multivibrator we have a trigger pin, that is trigger signal. Okay. So whenever I apply the trigger signal to this comparator, that time only it will produce the output here. Okay. So initially we assume that 0 and here the 1. So that process will be run, and that again again the output is 0. Okay, that time we trigger the input given to the circuit, so it will compare the value and it will produce the high output because of 1/3 is very high. So that time it will give an high output here. So that here 0 means output will be 1. Okay. Again the process will be continued. Again the S goes to 1. So that here there is no trigger applied to the comparator 2. Okay, it's clear? Good. So this is the function of monostable multivibrator. Okay. So now we have the components. Based upon this comparator output only, the flip-flop will produce the output here. Okay. So this monostable multivibrator waveform here. Okay. So in this waveform, this is our trigger input, this is our output, and this is our capacitor charging and discharging value. Okay. Now the trigger input. So whenever I already discussed in the diagram session, right? So whenever I apply trigger input to the circuit, that time only the output will be high, right? So let's see. Now I applied trigger here, the negative trigger only. Okay. So that time the output goes to high stage. Okay. Again it goes to low stage because of that set condition. That is compared to 1 output will be goes to